All right, good morning to pre-calculus. This is going to be our test 5 review or quiz 5 review. Okay, so let me go ahead and share screen so we can kind of get working on this. Okay, so what am I going to ask you? We are going to ask you to verify an identity. 2, we're going to solve an equation. Okay. 3, there's going to be a word problem from section 6.1. Okay, this is the right triangle stuff. And 4, there is going to be a word problem from 6.2, 6.3. Okay, I wish I could get as much of this stuff as I wanted to do for other videos, but yeah. Okay. So the identity that I have chosen, I've got 2 of them that are pretty common. Okay, looking back at my quizzes from previous semesters, I usually ask something like a triple angle identity. Okay, this is the name that we use for them. Okay, this is an actual name. If you Google this, you will see it. Okay, so the idea is like we're going to go ahead and say cosine of 3x, sine of 3x, or cosine of 3x. Okay, actually, let me go get those for us right now. Pause this. Okay. So like I said, this is Wikipedia. You're free to look them up. It's either going to be sine 3 theta, cosine 3 theta, and you don't look them up on the quiz. That's not what I'm saying. Okay. So this is 3 sine theta minus 4 sine cubed theta, and 4 cosine cubed theta minus 3 cosine theta. Okay. So both of those, they have the same little trick involved here for doing them. Okay. I don't really know which one is harder. They both look about the same to me. So I'm just going to go ahead and show you this one. I'll leave the other one as an exercise for the reader, as they say. Okay. So this is cosine of 3 theta. And we're going to utilize a well-known identity that 3 is equal to 2 plus 1. Okay. So this is going to be cosine of 2 theta, right? So we have to use the sum of angles 1 here, okay? So if you were saying, oh, I never have to remember that again, I'm like, yeah, I'm sorry, you do. So this is cosine 2 theta, cosine theta minus sine 2 theta, sine theta, okay? This was from sum of angles. Okay, so I am telling you, yes, you need to know the sum of angles for this exam, okay? Now you have to know the double angle formula because that's one of the things that was on here, and it's one of those things that's going to help you for a long, long time. So please do sum of angles. Okay, for cosine, 2 theta, there are 3 options. Okay, there is the cosine of theta minus sine squared theta. Okay, cosine squared theta minus sine squared theta. There's a 2 cosine squared theta minus 1 and a 1 minus 2 sine squared theta. If you only remember 1, that's the one I would pick. And if you want to get rid of your cosine, you could say, oh, well, this is 1, because you know that sine squared plus cosine squared equals 1. Since cosine squared equals 1 minus sine squared, right, we could say this is 1 minus sine squared theta minus sine squared theta. And thus we have 1 minus twice sine squared theta. Okay, so that is our possibilities there. Okay, so you need to know these. I only memorized 1, and I just kind of do the other ones real quick in my head to know that I can have all 3 of them. Okay, but all 3 of them are important. It depends on what kind of problem it is. Since, look at my values here. You have a cosine. On the other side, what do you have? we have cosines. So what we're going to do is we're going to say this is 2 cosine squared theta minus 1 times cosine theta minus, what's the double angle for sine? Something you should know. Okay, 2 sine theta cosine theta times sine squared theta. Okay, so let's make ourselves some room here. We've got 2 cosine squared theta minus 1 cosine theta minus twice, right? And we have, what do we have here? We have, oops, that's not the sine theta, that's just this theta, this sine. So we've got 2 sine squared theta times cosine theta. Okay, now using this identity here, right? Sine squared theta is equal to, so we can say sine squared is equal to 1 minus cosine squared. Okay, so here we have 1 minus cosine squared theta times this 2 times cosine theta, 2 cosine squared theta minus 1, oops, not there, there, and cosine theta. Okay, let's make sure that we didn't write that down. Okay. Minus here. Okay, so now we're going to distribute. We're going to say 2 cosine squared times cosine, that's 2 cosine cubed, cosine squared times cosine, minus cosine theta, minus twice cosine theta, because this comes in, minus twice, oh, nope, sorry, not minus. Minus times a minus is a plus. 2 cosine cubed theta. Okay, and now we're just going to go ahead and say, well, 2 and 2 makes 4 cosine cubed theta, minus 1 minus 2 is minus 3 cosine theta, and that is equal to our cosine of 3 theta, which is what we wanted to prove. Okay, so pick one. Okay, I'll pick one on a quiz and put it on there. So practice the other one. They both involve doing a sum of angles and then doing a double angle identity here. Okay, so you should know both of those. I said it's possible I could pick another one, but like I said, I looked through the previous semesters and almost always I pick one of these two. Okay. All right, solving an equation. I don't think I put on to go between, I only think I did this one to evaluate it between these 2 points, okay? So real quick, we are going to be looking at our raw hill. Here is our, okay, trigonometric equations. So we'll go ahead and take a look at that. Okay, start assignment now, please. And we're going to want something in the middle. I'm not going to give you the ones at the beginning. Didn't pick that one. Oh, that one looks glorious. Okay. That one looks glorious too. All right, if you can factor them, you should. However, okay, let's take a look at what's going on here. We've got a 2 cosine squared x plus root 3 cosine x minus 3 is equal to 0. It's going to be something like this, okay? So it's very commonly you're going to have to do a AC method piece in order to do this. However, these coefficients don't look very pleasant to me. Square root of 3 is not a coefficient I want to deal with. If only there was some way to solve quadratics, like if we had some kind of a formula that we could use to solve for quadratics. So can you solve this equation? Now if we let u equals cosine x, we can solve this equation, right? We have to use quadratic formula because I don't want to deal with this. So that's what we're going to do. Okay, we're going to say, well, u is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so you still have to know that. All right, and now we're just going to plug these things in. I know they're ugly, but we're just going to apply the formula here. Okay, we have u equals negative square root of 3, okay, plus or minus the square root of the square root of 3 squared minus 4 times 2 times c. If you're going to make a mistake, that's right there. Make sure you use the correct SIGN sign on both the A and the C values. Okay. The next place you're going to make a mistake is that it's all over 2 times A. Okay. Those are the two places. The most common mistakes made by students, made by everybody, is not getting the sign here and not doing the 2A down here. Okay, so be really careful about that. Follow your formula. If you have that correct, chances are you're going to get the rest of this just fine. So this is square root of 3 plus or minus square root. Square root of 3 squared is 3 minus, but there's a minus, so it's a plus. We have 4 times 2 times 3. Every way you want to do this. 4 times 3 is 12. 12 times 2, 24. Okay. All over 4. Okay. So now we're going to go with this. We're going to say u is equal to the square root of negative square root of 3 plus or minus square root of 27 all over 4. Now, what's the square root of 27? 27 is equal to 9 times 3. If I want square root of 27, we have square root of 9 times the square root of 3. What's the square root of 9? That's 3. So we have u is equal to negative root 3 plus or minus 3 root 3 all over 4. So let's break this into two pieces now. We've got u is equal to negative root 3 plus 3 root 3 over 4, or negative root 3 minus 3 root 3 over 4. Okay, negative 3 or negative 1, so we have negative 1 root 3 plus 3, that is 2 root 3 over 4. And a negative 3 minus root 3, right? So that's going to be negative 4 root 3 over 4. Okay. Simplifying, this is square root of 3 over 2. Simplifying, this is negative root 3. Okay. So all the way back up here, we know that cosine x, that was u, is either equal to root 3 over 2 or cosine x equals negative root 3. Okay. Use your calculator. Plug in root 3 for me just for a moment. Okay. Is it bigger than 1 or smaller than negative 1? So here we go. There's a cosine. I know that root 3 is negative root 3. It's negative 1.7 something. Okay. So I know that here's my line, y equals negative root 3. Does the cosine intersect with that? No, it does not. So we don't have to worry about that one. Does it intersect with root 3 over 2? Well, root 3 over 2 is about 0.886. So it intersects here, and it intersects here. So our answer here is going to be, okay, root 3 is going to be about 30 degrees, right? Or 30 degrees in the fourth quadrant, which is 330 degrees. So it's either going to be pi over 6, right? Or pi over 6 in the fourth quadrant, which is 11 pi over 6. We can go ahead and count, right? Here's 1 pi over 6, 2 pi over 6, 3 pi over 6. Okay, and all the way around until we get to 11 pi over 6. All right, so we're going all the way around to there. All right, so those are our two solutions, right? Our two solutions are going to be pi over 6 and 11 pi over 6. They did not have us go all the way around the circle. They just said stop here. So that's going to be our solution set. Chances are that's exactly what I've asked you. So this is pi over 6. okay, and then comma 11 pi over 6, all right? And those are our solutions here. Okay? So this is, I would not be surprised if I think something very, very similar to this. Okay. So if you find the one with the cosecant in it, we did that one in the examples. I didn't pick that one for a reason of like it added an extra level of difficulty of once you have these solutions, you really have to work out like what's going on here. And I decided that setting up an equation, applying quadratic formula, and getting a solution, that's probably enough. Okay, so that's what we have. Right. The next problem we have is going to be for 6.1. It's going to be a word problem. Okay, preview. Start assignment. Okay. Now, my face-to-face class found these problems to be pretty straightforward as far as what's going on here. Okay. And that's what we're going to do. Okay. That was not a bad choice. That was not a bad choice. So 8, 9. 10 is not a bad choice. Okay. I try my best. This one is a nice problem, but this struck me as a little too much to kind of digest for one problem. So I would not pick number 11. So because there's a lot to it, and it looks like I don't know. This one didn't look too bad. This one looked too easy, actually. And there's another one that kind of looked a little bit easy. Actually, they all look really straightforward. Okay. So let's see. Which one did I want to pick for you guys to do? Tell you what, why don't we do this one? Okay, so we've got a police car hiding between two bushes here. We've got an angle. We've got an angle. He cites point A. He cites point B. Okay, so it's 2 points. The angles are those. If there's a drawing, I try to include the drawing. Okay, you've experienced the fact that Brightspace tends to not appreciate me putting the drawings in. So I tried to make sure I did the same thing last time as I did for this one because there is a drawing. But try to be understanding with that. Okay, so that is our 50 feet right there. Okay, we've got our police car. We've got a point A, and here's our 62 degrees. Okay, here's our B, and we've got our 72 degrees here. Okay, we know that's 50, and we want to know. Do we want to know? We would like to know. Find the distance between A and B. Okay, so we want to know what the heck is going on here. So effectively, we've got two triangles to deal with, right? We've got we're trying to figure out like what is this distance? What is this distance? So I've got an adjacent side and I need an opposite side. And I have an angle. Can you tell me a trigonometric formula or a trig equation that is going to relate the angle, the adjacent side, and the opposite side? Okay. That's going to be tangent, right? The tangent of an angle is equal to the opposite side over the adjacent side. Okay, so why don't we use tangent? Okay, what am I trying to find? Trying to find the opposite side here. So we're going to have the adjacent times tangent is equal to the opposite. The adjacent side is 50, okay? And then we have the tangent of this angle. Actually, both triangles here, this one too, right? It's going to be 50 times the tangent of that angle to give me the opposite side, okay? So for triangle A, triangle B, okay? So what we're going to do is we're going to say 50 times the tangent of 62 degrees, okay, is equal to opposite side 1, okay, and 50 times the tangent of 72 degrees, okay, the 50 is given, that's opposite 2. So this is going to be equal, and then we're going to have to add these up, okay? So let's go ahead and calculate those. Okay, so what do we have here? We have clear. We have mode is in degrees, excellent. Okay, so we have 50 times tangent of 62 degrees. Okay, it's 94.04. And then we have, what we have? We have tangent, or 50 times the tangent of 72 degrees, okay, is equal to, and we ended up with 153, okay, 153.88 degrees, 0.88 feet rather. And then we just add those up. Okay, we're just going to add those up. That's going to be 94.04 plus 153.88, right? Very good. So that's 247.92 feet, and then we're good. Okay. So our distance is, what do we have? 247.247 no, the nearest foot, 248. All right. 248. Okay, look at that. Okay, then we say we have a motorist takes 2.7 seconds to pass from A to B. So motorist takes 2.8 seconds to go from A to B. Okay. And we are going to go ahead and use that to get feet per second in 1 decimal place. Okay. So we're going to be moving 248 feet in 2.8 seconds. Okay. So we're going to go back here and we're going to say this is 248 divided by 2.8 seconds, 2.8 seconds, 2.8 seconds. You get 88.6 feet per second. All right, let's cross our fingers to hope that that's accurate enough. Okay, now I did not ask you this part. Okay, if there is a convert it from feet per second to miles per hour, like I'm not expecting you guys to be able to do that. Okay, I mean I know you can, but I'd feel compelled to like type in like what the conversion factors are. But I know that there is 3,600 seconds to 1 hour. Okay, and then it's 5,820 feet for 1 mile. Okay, and again, this is something you could easily Google, and I would not. If I'm going to ask you a conversion, I would definitely put the conversion factor in there. The only one I wouldn't give you is the time. Okay, because that one you can know that there's 60 seconds to a minute and 60 minutes to an hour. 60 times 60 is going to be 3,600. So I wouldn't feel compelled to tell you this part of it, but I would feel bad if I did not give you what was going on here. So we're going to do 88.6 K times 3,600 divided by 5,820. I hope it's not 5,280. I never remember which one of those is right. And we could say this is 54.8. That seems like a reasonable speed that people would do, miles per hour. And we'll say 58, 54, 55. Okay. And I didn't like it. How about we try 5,280 instead? Okay. Like I said, I always mess those up. Something I should always look at. Divided by 5,000. 280. But like I said, I would not ask you to do this. Okay, so at 60. That would be our speed. Okay. I come from Pennsylvania, so I'll just tell you that the speed limit was like 55 miles per hour, but even on the freeway for the longest time. Okay, so that would be a thing. Okay, next, law of sines, law of cosines. We will do two of them. It'll be a word problem. Okay, I promise you it'll be a word problem. We'll do a video for that one eventually as well. Okay, so what we're going to do, we'll preview. Okay, you have to know law of sines, you have to know law of cosines. So law of sines, that's sine of A over the side A is equal to sine of B over the side B equals sine of C over the side C. Okay, this is a nice easy one, so we'll be able to do that. Technically, you should always use law of sines when it's a right triangle, when it's not a right triangle. Okay, but I know a lot of students get really excited to use this and they use it all the time. It does work, but you should probably use right triangle trig rather than law of sines to do stuff. Okay. The issue, this is why it's a word problem, okay? The issue with law of sines is that in the middle of this, you could get two possible triangles, okay? So there are cases where it's like, which triangle is it? Like, yes, it's both. So that's why it's usually a word problem where you can more or less take the picture to say that's what's going on, okay? Not precisely, but I'm not going to try to lie to you on the picture and then say, well, you should have known. No. Okay, I would give you a hint. Like, first off, it wouldn't be a word problem, and secondly, it would be, if there are two triangles, please solve both of them. Okay, perfect problem here. So we've got a mountain. Okay, and we have elevation to the top of the hill from one part is 31 degrees, and from the other part is 22 degrees. Again, I tried my best to make sure that the pictures would turn out. Please forgive me if they didn't, but I'll try to fix that. I did, I checked, but who knows. All right, so we have 31 degrees, okay, and then we have another spot here. This is 22 degrees, and then this spot here, this is 260 feet, okay. So what we'd really like to do is set things up to get a law of sines problem going, because we know we're in the law of sines problems. Okay, how high is the hill? What we really want to know. Okay, what we really want to know. What's this? Okay, we really want to know what that is. Notice we do not have, right, a right triangle here, so we cannot use just a tangent. It's not going to work. And we have a triangle over here. Okay, so let's see if we can cut this triangle out. So we're going to do here, here, and here. We know this is 22 degrees. Okay, we know this is 31. What do you think this one's going to be? It's going to be 180 minus 31, right? So that's going to be a 149 degrees. That's 11, 12. Yeah. Okay. So this is 149 degrees. So what can we say about this one? All right. Could say 180 minus 31, 149 plus 22. Okay, it's 171. The triangles have to add up to 180 degrees. So this is 9 degrees up here. Okay, so this angle here, this is 9 degrees. Now we can do all of the pieces we would actually like to do. Okay, we know that let's go with it this way. We know the opposite of the 22. So the 22 and that side are opposites. Okay, we know what these are and we know what this is. What I really want to do is get what this angle is or what this side is, because once we know a side and an angle, right? Once we know that side and that angle, right? We know that this guy here, this is 31 degrees. Okay, if I knew the side, what we could do is use our sine function to say opposite over hypotenuse is equal to the sine of the angle. So I really just want this one. Okay, we just needed to set up so that we have an angle attached to a distance. So I needed this 9 degrees in order to match up with this 260. Okay, so what we're going to do is we're going to say that the sine of 9 degrees, right, is equal to 260 feet, and that is equal to sine of 22 degrees to, I don't know how many feet that is. Okay, all we're going to do is solve for b. So we're just going to say b is equal to, or let's do it in 2 steps. Cross multiply here. So we're going to say b times sine of 9 degrees, okay, is equal to 260 feet times sine of 22 degrees. So b is equal to 260 times sine of 22 degrees over the sine of 9 degrees. Okay, and there we go. Okay, so let's go to the calculator. We have, clear, 260 times sine of 22, parentheses, divided by sine of 9, parentheses, equals, and we get an answer of 622 point something feet. Okay, 622.6 feet. So that is this side. So this is this side. So that was 622.9 feet. 0.6 feet, rather. 6. Okay, now, do you know something that will relate the opposite, the hypotenuse and the angle? So, oh, wait, that's sine. Sine of 31 degrees is equal to the opposite value divided by its hypotenuse. Okay, so this is 622.6 times sine of 31 degrees. This is equal to the opposite value. This is a good problem that I would have picked because it requires you to like figure out one triangle to get the pieces you need to solve for the next triangle. So that's a very likely problem I would give you. Okay, so 622.6 times sine of 31 degrees. Okay, make sure that the long side is the hypotenuse. Okay, and then our height is equal to 320 degrees, or 320 feet rather, 320.6 feet. Okay, so 20.6, and then we'll be all that good. All right, so hooray. All right, so that's law of sines. Okay, so practice some homework with these. Okay, they're not too bad. The ones in the middle here where you have to do like 2 possible triangles, they could be a little tedious. Okay, you might not get a triangle, you might get 1 triangle, you might get 2 triangles. It's a thing. Okay, but we have to watch out for that. All right, next one. Okay, law of cosines. You're only going to get one of these problems. Okay. Okay, law of cosines. Law of cosines is another. Law of cosines is safer than law of sines because law of sines can give you like 2. You can get an ambiguous case where you have 2 of them. Law of cosines don't do that. Okay. So law of cosines is equal to c squared is equal to a squared plus b squared. So that's Pythagoras, right? So you should know that. And then there's like a correction factor because it's not a right triangle. Okay. So that's how you memorize it. There are two other ones that the book will tell you to memorize. B squared is equal to a squared plus c squared minus 2ac times the cosine of the angle between these two. And a squared is equal to b squared plus c squared minus twice bc cosine of the angle between them. There. I've only ever memorized this one. I just relabel my triangle to get the c and the a and the b and the c in the right position so I can solve it. Okay, I've never done all these three of these formulas. Okay, and I recommend don't memorize all of these. And when they solve for the cosines, don't memorize those either. This is why we taught you algebra. Okay, so those are a law of cosines. Yes, you have to have them memorized. If you memorize all of them, so be it. If you memorize one of them and turn it around, so be it. Okay, I don't recommend memorizing all of them though. Okay, your book really likes you to memorize all of them. I did not. Let's see here. Showing off the tower. See if I can find one with a picture on it. Ugh, don't want to do that. All right, we'll use the one with the picture. So here is our triangle. 128, 153, 94. This is a 0.4. Okay, so look here. We don't have any angles, do we? So if you want to do like a sine of A over the length equals sine of B over a length, you have two variables. You don't know what A, B, or C is. Okay, this is A. This was B. This is C. See the little points here? So we have that. All right. So we're just kind of stuck with this. Okay. So if I try to apply law of sines here, I'm stuck. I don't have enough information. Okay. So what's our alternative? Law of cosines. Okay. So, but wait, I don't have the angles. Like, you don't need the angles. Okay. If you have all the sides, you don't need the angles. This is c squared is equal to a squared plus b squared minus 2ab cosine of c. Can you solve for the cosine of c? You sure can. So that's going to be 2ab cosine c is equal to a squared plus b squared minus c squared. Okay, just swap these two, put this over here, put that over there. And then cosine of c is equal to a squared plus b squared minus c squared all over 2ab. Okay, and then we just have to use this several times to solve for it. Okay, so here we go. We're going to say that cosine of, pick one. Okay, I'll pick c to match the picture. That's fine. Okay, so we'll say that cosine of c is equal to 94 squared plus 153.4 squared, a squared plus b squared, a squared plus b squared, okay, minus 128 squared, that's the one that's across from c, okay, divided by 294, 153.4, okay, we'll just go to our calculator. So we'll take cosine of c is equal to all right. Actually, this is a good problem because I'll show you why as soon as we get to part 2 here. So this is 94 squared plus 153.4 squared minus 128 squared, okay, equals divided by parentheses 2 times 94 times 153.4 equals, Okay, cosine C is equal to 0.5542. So C is equal to the inverse cosine .5542, dot, and that is equal to, we're just going to say our previous answer, and then equals, it's 56 degrees, 0.34 degrees. Okay, so on my little picture here, okay, my angle C, 56.34 degrees. This guy here, 56.34 degrees. Now I've got a side. Okay, we've got a side. I can use the side to break the other angle. Okay, so pick whichever angle you like. I'll pick A. Okay, so we can say something like the sine of 56.34 degrees, right? To the, what's the opposite side is 128. That's my opposite side, is equal to the sine of A, and the opposite side is 153.4. Solving for sine of A. So we've got 153.4 over 128 times sine of 56.34 degrees is equal to the sine of A. Okay, so we got 153.4 divided by 128, okay, times sine, okay, of 56.34. 0.9975 is equal to the sine of A. Take the inverse sine, so inverse of your sine. Okay, and we got 85.96 degrees here. Okay, so my angle A, 85.96 degrees. Okay. 85.96. All right. How do we get the last one? Well, we know that we have 56.34 plus 85.96 plus something, angle B. What's the three angles of the triangle supposed to add up to? So getting that last one is not going to be too much of a problem. Okay, so we have 6.34 plus 85.96 equals, let's make about 38 degrees. So we 180 minus our previous answer. So 37.7 degrees is equal to our angle B. Now, 7.7 is equal to angle B. And that is how you deal with law of cosines. I like this one because it forces you to, what does it force you? You can go the long way around and just keep using law of cosines, it's fine. But the quick way to do this is to be able to use law of sines and law of cosines, so it actually gets both methods at one time. Okay, so I'm partial to problems like this because it does a lot of different things for us. Okay, so practice law of cosines, practice law of sines. Okay, practice 6.1, that's our application problems. Okay, 5.4. No, 5.5 is trigonometric equations. So just to review, it's up at the beginning of this thing, but let's put it at the end. So 5.3, double angles. Okay, again, I am partial to an identity that does triple angle. 5.5 is trig equations. Partial to something that's quadratic, where you have to factor. Okay, it's possible both solutions could be there, so don't just automatically throw out one of them. Okay, well, I don't like that one. Like, chuck it. Don't do that. Okay, triple angle. Okay, 6.1, this will be a word problem. Okay, most of my face-to-face class was very happy about this one because, it's nice. And 6.2, 6.3, law of sines, cosines, also a word problem. Okay, that water fountain, the sprinkler system one I liked. Any other one where I have to use some kind of a mountain, but you get two triangles that you have to deal with, also pretty good idea. Okay, so those are the 4 problems. Okay, you have to know formulas, you have to know sum of angles, double angles. Okay, law of sines, law of cosines, plus all the other stuff, all the other formulas you've memorized up until this point. Okay, so you still have to know Pythagoras ones and things like that, but those are the ones that are featured. Tangent, the sine over cosine, stuff like that. Okay, those are the ones that are featured. Good luck, and well, hopefully you guys will do well. If you're still watching, write your stuff down, kind of like what I'm doing. Take a picture of it. Okay, if you can, change it into a PDF, submit it into the assignment, and then go ahead and do that. You do not have to sit there and write through your steps in Brightspace trying to use the editor. Okay, I know that takes a long time, and I know it's difficult to read. So I would encourage you to not write everything out that way. Okay, so very well, and we'll see you soon. Thank you.